So hello guys, this is another question from IIT JEE PYQ. The question is, a particle which is constrained to move along the x-axis is subjected to a force from the origin that is equal to f of x that is equal to negative of kx plus alpha x cube, right? Here k is a positive constant, k and a. For x is equal to 0, the functional form of kinetic energy ux of the particle is what? That we have to tell. So we have to check out here first, this force is conservative or not. Since it is the expression for x only and it is acting in the x direction, so I can say the curl for this force will be equal to 0. Del cross f will be equal to 0. That means work done by this force on a closed path, that will be equal to 0. Since it is a conservative force now, that means since it is a conservative force, I can say that there will be some potential energy associated with this force. Then from the Stokes theorem I can write F will be equal to negative of du by dx, because this force is acting in the x direction only. So the potential energy will also be a function of x here. And now I have to substitute the values of this force F. So the value of force is what? K x plus alpha x cube, that is equal to negative of del u. Okay. Now since del u by del x, so I am taking this integral term here, that will be equal to del u is equal to kx minus alpha x cube, okay, dx. So let me integrate on both sides and I am taking the limit. Since in the question it is given that this force is acting on the body about the origin, from the origin, that means at origin at x is equal to 0, I will have to take potential energy is equal to 0, and at some value of x, let us suppose this potential energy u. Okay, so I can write here that u will be equal to, on right hand side, what is the integration of this k x dx will be equal to x square by 2, that limit from 0 to x, minus the integration for this term will be k x to the power 4 by 4 from the limit is 0 to x. So the expression for the potential energy associated with this force I am getting k x square by 2 minus alpha x to the power 4 by 4. So this is the expression we are getting. Now we have to check out the graph between this potential energy and this x, that is the displacement, okay, that position. So graph between the potential energy and this is our u on y axis and this is our x, that position of this particle, this is our origin. So the graph between this for this function will be just looking like this. Okay, so graph for this potential energy with respect to the position of the particle will be like this. So this will be our option, we have to choose from the 4 options. I have taken here the statement only. So this is the answer for this question.